which most of you have done that, and then you're solving the system. I want you to use the strategy of substitution because we've already talked about the strategy of elimination. So if you don't remember that from Algebra 1, make sure that you're using your resources like you did last time, okay? But I don't want you Googling the actual problem. If you're going to use your resources, I want you to look up the strategy, not the problem, okay? I want you to figure out the problem. But if you need to look up the strategy, you can do that. How are you guys doing over here?
I'm looking through the other.
That's not in the notes. This was back from Algebra 1.
Oh.
So,
I think. I think it's like where you have to set up like.
Explicitly talked about substitution in here. You should have seen it in Algebra 1, so I wanted you to kind of review that. If you didn't see it in Algebra 1, it's okay because you're going to get it today. But I want to just look at some students' work, and we can see if we really are following substitution here and if we got the right answer. So let's go through. All right. So it looks like, and this was Savannah. Thank you, Savannah, for sharing your paper with us. So Savannah, do you want to talk a little bit about what you did?
Well, like, I took 6x plus 6y equals 0, and I isolated y, and so y equals negative x, so then I plugged negative x into the first equation to get what x equals.
Okay, so I'm going to stop you right there. So what Savannah's saying is that it looks like over here she moved her x over, her negative 6x over, and then she solved to get y by itself, right? So when we're doing substitution, we want to first get a variable by itself. I would make things easy on us, and I would pick the easiest variable, easiest equation. And in this case, if I had worked with the first one, it probably would have ended up with a fraction. It would have been okay, but maybe not as fun. So it looks like the second equation in this case is the easiest. So Savannah, is that why you chose it, or did you just, okay. And then what did you do from there? So you got y equals negative x, then what?
I plugged in negative x to the first equation 4y.
Okay, so right here is where she substitutes it in. Notice that she puts parentheses around her variable when she substitutes it in. So whenever you're substituting in for a variable, make sure that you're using those parentheses. And then, do you want to walk us through the rest?
Well, then I got x equals negative 2, so then I just plugged negative 2 into one of the equations to get y.
Yeah, perfect. So again, when we're solving the substitution, we're getting a variable by itself, taking that variable, plugging it into our equation that we didn't use yet, working it through. And then once you get your first variable, you can plug it into either equation, just like we did with elimination, to solve. So thank you, Savannah. Good job. One more. So Cameron also shared his paper with us. And it looks like he went a little bit of a different route, but kind of got the same results. And so, Savannah, when you did it, what variable were you solving for? Y. Okay, so what variable does it look like Cameron solved for? Go ahead, Jalen. X. So does it matter which one you're solving for? Nope, you just plug it in. And so he did that and worked it through and ended up with the same answer. So we talked about, and we have x equals negative 2 and y equals 2, but what's another way that we could write that solution? Go ahead, Jaden, sorry. Yeah, perfect, coordinates. So we could also write it as a coordinate, x comma y. Why can we write it as a coordinate? What does it represent if you're thinking about the graph? So think about the graph. Careful. So what type of equation is that first equation? What? Okay, thank you, Jalen. So linear, right? What about the second? What about the second equation? What type of equation is that? Standard form of what? A line, so linear, right? So we have a line and another line, and if our solution is a point, where on the graph would we find our solution?
So where it intersects.
Perfect, where they intersect, and that's why we can write them as a point, right? Because on the graph, it's going to be where they intersect. So that's going to kind of lead us into what we're doing today. So go ahead and turn to your note guide.